All right, so today we're going to be looking at a trapezoid. So if you notice your family tree, it just comes straight off of the quadrilateral. There are two types, or actually there's three types. There's your regular one, and then you might have an isosceles trapezoid or a right trapezoid. And just think about those names because their name implies their shape. If it's an isosceles, that means that these two sides are congruent. Your right trapezoid means that it has a right angle. So let's open it up to properties of trapezoids. And we'll start here. So like it showed on your family tree, it has the two properties of a quadrilateral, meaning your interior angles add up to 360, and it has four sides. It has exactly one pair of sides that are parallel. So if you look, in this case, the top and the bottom are parallel. And it has same side interior angles are supplementary. And remember, supplementary, if my pen will work, supplementary, because the top and the bottom are parallel, that makes this side a transversal. So they're going to add up to 180 degrees. We'll come back to the examples below, but first what I want to do is go and look at the two trapezoids we were talking about, because our examples include right trapezoids as well as isosceles trapezoids. So looking, your right trapezoid has all the properties of a trapezoid, including exactly one pair of sides that are parallel. So in this case, it has same side interior angles are supplementary. So your same side, meaning this side is supplementary, this side also adds up to 180 degrees. However, in this case, the new part now is that it has two right angles. Remember, right angles are 90 degrees, and you can see from the picture it's going to be this side and that side. Oh, I guess you can't see from the picture. There you go. So then let's turn the page. Let's look at isosceles triangles, or trapezoids. I think I've been saying triangles. Trapezoids. So let's look at our isosceles trapezoids. It has all the properties of a trapezoid. Exactly one pair of sides are parallel. Same side interior angles are supplementary. However, now when looking at the trapezoid, your legs are congruent. This is the part that makes it isosceles. This leg is congruent to that leg. Your diagonals are congruent. So be careful here. It's saying your diagonals are congruent. However, once they're intersected, it means that the top is equal to the top and the bottom part of your diagonal is equal to the bottom part. Okay? It's not like a square where they're each the same. This length is the same as this length. Sorry. This length is the same as this length. However, when they intersect, it creates a little bit of a difference. And then the last part, both pairs of your base angles are congruent. Because it's an isosceles trapezoid and your sides are congruent, this means that your base angles are also going to be congruent. Okay, so now that we've gone over the characteristics, let's turn back to our examples so we can see how we apply these characteristics. So you want to be sure you read the information that they give you, because that's important. We need to know what type of trapezoid are we looking at. So number 9 says, if ABCD is a trapezoid, find its missing measure. All right, so it wants the measure of angle A, which is this angle right here. Well, if we remember, the one right above it, same side interior angles are supplementary. So to find the measure of angle A, we would say 180 minus 76. That gives it that this angle is 104 degrees. Then it wants the measure of angle C. So in this case, its same side interior angle is D, so you would do 180 minus 143. So that gives you that the interior angle there is 37 degrees. Number 10, if STUV is an isosceles trapezoid, that's important. Isosceles trapezoid means that this side is congruent to that side. Finding each missing measure. All right, so the first thing it wants is a measure of angle T. Well, it has same side interior angles are supplementary. So 180 minus 71 means that that interior angle is 109 degrees. Angle U, we're not really sure about just yet, even though I could tell you. Let's go to angle V. If we have an isosceles trapezoid, that means that our base angles are the same. So if angle S is 71, then angle V is 71. And if we know angle V is 71, now we can find U. It would end up being the same up here. So while they don't say it, if your base angles are the same, that means perhaps your top angles are also going to be the same. Looking at number 11, if PQRS is an isosceles trapezoid, find the measure of angle P. So if we can find the measure of angle S, they're going to be the same. Since we know this one is 11x minus 16, then we know that this one over here, angle R, is 11x minus 16. We know that same side interior angles add up to 180, so we can say 11x minus 16 plus 5x plus 4 is equal to 180. When we simplify, we get 16x minus 12 equals 180. If we add 12, we get that 16x is equal to 192. Divide by 16, you get that x is equal to 12. Once we know what x is, we can substitute it in here. So 5 times 12 plus 4 is equal to 64 degrees. If we know angle S is 64, then we know that angle P is 64 degrees. So we could say angle P equals 64 degrees. Number 12, if MNOP is an isosceles trapezoid, there's our favorite word again. This is congruent to this. Find each missing measure. So remember, if you go back to the isosceles trapezoids, let me find their characteristics. This isn't completely complete, but your legs are congruent. Diagonals are congruent. Look at your picture that we drew. So if diagonals aren't congruent, if this is 8, then this is 8. If this one's 14, then this one's 14. We'll have to do this one 3. If that one's 11, then this side over here is 11. So let's see, they ask us for OP. So that would end up being 11. CO, well, it's the same as this side, so it's going to be 8. And then it wants NP. Well, this side, or this length right here, is 14. So we have 14 plus 8. That's going to get us to 22. Sorry. 22. Okay, so we've looked at our trapezoids, and I want to introduce one more thing. The mid-segment theorem. All right, so go ahead at the bottom. I want you to write mid-segment theorem. All right, if we have a trapezoid, and it has a mid-segment, meaning it splits your sides in half. We can say that the top plus the bottom divided by 2 is equal to our mid-segment. Okay, so if we were to highlight, we would say our top and the bottom, top, bottom, is equal to the length of the midsegment. All right, so that's what we're looking at. Let's look at number 13. It says, if ABCD is an isosceles trapezoid, find EF. So what we would say is that the top plus the bottom divided by 2 is equal to our midsegment, EF. So we would say 41 plus 49 divided by 2 is equal to EF. If we did 41 plus 49, we get 90 over 2. So we get that EF is equal to 45. And that's not so bad. Let's add a, oh, we didn't put algebra in yet. Keep in mind, some of them might involve algebra. So we look at number 14. This time it might not be as easy. They gave you the bottom, and they gave us the mid segment, and they want us to find the top. So this is our x. So we would say x plus 22 divided by 2 is equal to 19. You have to use algebra. You got to get rid of your fraction. Multiply both sides by 2. X plus 22 is equal to 38. Subtract 22. You get that x is 16. So this means that HI is equal to 16.